give you, okay? I would give you this big old circle with a bunch of dots that are the same color, and since all of them are the same color, your answer would be that this is an element. Even though there are multiple ones of them, they are still all the same, and therefore this is an example of an element, okay? Okay. However, elements can also be what we call diatomic. It's a fancy word. You do not have to memorize these 7. You don't have to even remember the word diatomic. But dia means 2, tomic means atom. Naturally, in oxygen, hydrogen, nitrogen, all of these 7, they will naturally show up with a pair, as a pair. Because they like to have a friend. Naturally, they want to have a friend, but their friend is going to be their twin. Okay? Even though there are 2 atoms, this is still considered an element because they are the same. They are a copy of one another. They are the same. They are the same color. They have the same letter. Okay? Elements are all the same.
All?
Not between one another, but if you are classifying an element, that means that you're telling me everything in that substance is the same. Okay? So if I were to add little green dots to my diagram up here, just like this, if I gave you a picture that looked like this, you would still classify it as an element. Because everything is still the same. These are all the same color, right? And even though they're touching, which if they're touching, that means that these molecules are chemically combined. Okay? They are chemically combined. They are stuck. And it's going to take a lot of energy to split them apart. Okay? Are we good on elements?
Hold on.
Yeah. They can be monotonic or they could be ditonic, which means they could be alone or they could have a pair. But if they have a pair, they have to be the exact same. Okay? They have a pair, they have to be the exact same to one another. They gotta be twins.
It was funny.
Thank you. Material.
Right here. It was still funny.
Ha. All right, are we good now? Yes? Okay. Let's move on to compounds. Compounds, okay, as we said earlier, compounds are multiple elements put together. So since they are different elements that are put together, their dots are going to be different colors, not the same anymore. They also have to be touching, which means that they have to be chemically combined. So in order to be a compound, they have to be different colors and they have to be chemically combined.
Where was Morrison?
Okay? So on my diagram up here, if I were to add on a red dot to every single one of these and make multiple compounds of the same compound, okay? If I gave you this picture, you would tell me that it is a compound. Because they are all the same. Even though there's there's amount of compounds. There's 1, 2, 3, 4, 5, 6. I drew 6. But the total amount of types is just 1. Okay? So therefore, this is a compound. Okay? Okay. Are we good? Okay. Mixtures. Now we're getting a little bit fancy. Mixtures are multiple compounds. Hold on, before.
Boom!
I don't want you to write all this. You don't have to write all this, okay? Just listen to me. I want you to draw the picture, but don't write. I've always wanted you to draw the pictures. I said that at the beginning. Mixtures are going to be multiple elements or multiple compounds together. So, this one right here, how many different types of molecules do we have in this picture? How many
10.
different types? You said 2, right?
I said 10, but.
No.
I thought it was 7.
We have 2.
Oh.
We have 1 here because if they're touching, that means that they are 1. Okay?
Oh.
We have 2 different types of molecules. We have 1, 2, 3, 4 different types of atoms or elements, okay? But we have 2 different types of molecules. Okay? This is a type and this is a type. This is the same type as that one, so we're not going to count it twice. This is the same type as that one, so we're not going to count it twice. Okay? We have 2 different types.
I just drew that on compound.
We have 2 different types of molecules. If we have more than one, actually I'll get to that later. Since we have 2 different types of molecules, okay, we have 2, is this a compound or an element?
Compound.
How do you know?
2 different types.
2 different types, 2 different colors. Is this a compound or an element?
Compound.
How do you know?
2 different colors.
2 different colors, okay? And they're touching, right? So this would be a mixture of compounds. That is how you would describe this one, as a mixture of compounds. We have 2 different types here, but I could have thrown in some pink dots, okay? And then it would have been a mixture of elements and compounds, because those pink dots would have been the element, okay? We're going to do a lot of practice with this today. Okay. I will never ask you to classify whether a mixture is a homogeneous or heterogeneous with a picture like this. That is not a part of this class. If anyone down the line wants you to do that, fantastic, great for them. I will never ask you to tell me whether it's homogeneous or heterogeneous.
Unless you
I
can
will
physically see the object.
Unless you can physically see the object, exactly.
So smart.
Okay? But on these diagram pictures, I won't ask you. But I do expect you to tell me whether it's a mixture of elements, or whether it's a mixture of compounds, or whether it's a mixture of elements and compounds. Okay? That's what I expect you to do. We'll do some more practice with that. Do I have any questions right now? Okay, get out a whiteboard and a